have seen the domain of a function. Now the image of a range of a function is the set f of a. Okay, so it's the set of all mapped values for every x in a. Okay, so for instance, if I have again f of x is x squared, right? And I'm taking the domain, let's say minus the square root of 2 to the square root of 2. Okay, so that I'm only considering this closed interval as domain. Then f of a, the domain of it is, sorry, the image of this domain is, if you think about it for a second, it goes from 0 to 2, right? So every negative number from minus square root of 2 to 0 gets mapped to the square root, sorry, the square of it. So this is minus square root of 2 gets mapped to 2, and then every other values, if we graph it here. So this is minus 1 minus the square root of 2, 1 square root of 2. This value, this is x, and if we plot here the value of f of x, this value gets mapped to 2, and then all of these values go like this. So we've painted parabolas before, and these go like this. Okay, so this is the set. Okay, this taking this set A as domain, the image is goes from 2 to 0, and then from 0 to 2. So if you focus on what's this set in the vertical line, okay, this is from 0 to 2, so this closed interval 0 to 2. I hope this is clear. And so likewise, we call the image of this set C a subset of A, this set. Okay, the image of C, so the f of C is the set of all map values given that x is a member of C. Okay, so for instance, in this case, the domain of x squared is actually the real line. Okay, right? So the maximum domain yeah, I haven't said it, but so we say that the domain of a function, a domain is maximum if f cannot be defined for numbers that don't belong to the domain. Okay, so for instance, if we take the function x squared defined in this domain, so f of a to the reals x to x squared, this domain in this case wouldn't be maximal, right? So if you look at this, we can think of numbers outside this domain that serve as valid input for this formula, right? So if you take, for instance, 3 is outside this domain, but 3 squared exists, right? So we say that this domain is not maximal. Okay, the maximal domain for x squared is actually the real line. Okay, because you can plot this function, this parabola, forever. Okay, it goes on for every negative number. You can compute its square, and the same for every positive number. So that's the maximal domain. Okay, so you could say the image of x squared when you consider the maximal domain. Let's see if I don't have a space here. So the image of x squared when you have f of r as the domain to r. Okay, the image in this case, so f of the reals is, and I'll give you a minute to think about it, is actually 0, infinity. Okay, because if you take the set of all possible values, they just, in the vertical line, they just touch this half axis, the positive half axis with 0. Okay, so yeah, the kind of quick way to think about it is the domain is in the horizontal line when we plot the figure, the domain is the set of all values that you can use to plot or to input as the function, and the range is, or the image is, the set of all values that get mapped to. Okay, I hope this is clear. Okay, now the inverse image of a set B that belongs to the reals, it's a subset of the reals, is the set f minus 1 of B, is all numbers belonging to the domain, so x in the domain, such that the mapping of this domain belongs to B. Okay, and it says note that f minus 1 of B is a subset of the domain. So as before, as I said, I take this set C minus the square root of 2, and then I map it with the, again, f of x is x squared, right? F of C is 0, 2, as I just said. Well, f minus 1 of, and let's call this B, for instance, right? F minus 1 of B is C. Do you see? Okay, so if I take this set C, I map it, okay, and then I get this set. This is the set B. Okay, this is C. Let's see, it's domain or subdomain. This is the range of C, or the image of C, and then the inverse image of B is the set C that gives you this this B when you mapped it by F. Okay, so you map it by F and then you go back to the domain. Okay, so that's why the inverse image of B is a subset of the domain, right? So let's see. The graph of a function f of x is what I've been doing here. So it's the subset of R2, so the plane. Okay, this is the plane, two-dimensional plane, defined by the points x, f of x, when x belongs to A. Okay, so what I'm saying, what this is saying is that, you know, you take x, okay, point x, and then when you assign this value, this is f of x here. Okay, this point here in the plane, if you use Cartesian coordinates, okay, you take the plane here, this is the point x, f of x, right? Well, if you do that for every x in the domain, and you join the dots in a sense, you get the graph of the function. Okay, and this is the usual way we use to represent a function, right?